Algebra 1, Common Core, Unit 4, Section 7, Sets, Inequalities, and Notation. So, Unit 4 has been all about solving equations. And what we're getting into now is solving inequalities. But before we can really get into solving inequalities, which is going to be video 4.8, we have to kind of know what inequalities are and sets and certain notations and things like that. Up until now, when we solved the equation, we got x equals 5, and so the answer was 5. That was it. Well, now when we solve inequalities, we get answers that are sets of numbers. And I know you could read this yourself, but let me underline a couple of key features here. That a set is a collection of items. So we could have an answer that is a set, such as this set right here. It can be expressed by they're calling this a roster. 5, 6, 7, 8, 9, meaning all of these answers or all of these numbers are the answer. All of them satisfy the solution. And this would be considered the set of integers from 5 to 9 inclusive. The concept of inclusive, meaning like if you say pick a number from 1 to 10, you are typically saying that in the context that you can pick the numbers 1 and 10. Pick a number 1 to 10, you could pick the number 1. Well, pick the numbers 5 to 9, meaning you can pick numbers 5 and 9, but it could not be inclusive, meaning the numbers from 5 to 9, but not including 5 to 9. That would just be the numbers 6, 7, 8. Just the numbers between those. 5 and 9 are the boundaries. And I'm sure you're familiar with inequality symbols. The greater than symbol, the less than symbol. And then when we put a little slash underneath it, it becomes greater than or equal to and less than or equal to. And the or equal to piece, that's kind of like the inclusive piece. Are we including that boundary number? I think this will make more sense when I get to some examples. But first, real quick, how do I tell the difference between greater than or less than? That's a common issue, is people see a sign like that and they kind of, forget which one is which. I've heard a lot of different theories and different techniques, different tools to help you remember. The two that I like the most is you could think of it as an arrow, and see how it's pointing to the left. Well, pointing to the left, that's the lesser numbers are on the left. Like if you picture a number line, the less than numbers are on the left side. So I like that. I also like that, less than starts with L. A capital L looks like this. And if you kind of take this L and rotate it a little bit, maybe close the angle a little bit, it becomes a less than sign. So it kind of looks like a squished L, less than does. So that's how you can, maybe remember that. I've heard a lot of different things of Pac-Man and stuff like that. But you need to remember which symbol is less than, which is greater than. But once we throw a line underneath it, now it's less than or equal to. So a set can be expressed in inequality notation. So something like this, that's considered inequality notation. And what that says is, right here, x is greater than 5. And we read left to right. So whatever's on the left, we say that first. And so x is on the left, so x, and then we say is greater than, for that little greater than symbol, 5. So x is greater than 5. And what that means is that 5 is not one of the solutions to this. When we say x is greater than 5, it's not greater than or equal to 5. That would be different. Greater than or equal to 5 would include 5. But just greater than 5 does not include 5. It's only numbers greater than 5. If we're talking about integers, then it's 6, 7, 8, 9, 10. And you'll see a lot of times that's like a common trap that a Regents exam would ask. You'll say, what is the greatest integer that satisfies the inequality? And you'll get this answer and people will say, oh, the answer is 5. But the answer here would be 6 because 5 is not included in this solution. Now, if it was greater than or equal to, then 5 is the smallest integer, I meant to say. If we're not including integers, then of course there's all sorts of decimals and things like that. But that less than, the equal to symbol, that equal to bar, really has a major impact. So you're probably familiar with basic inequality symbols like that, but you might not be familiar with them in this type of notation. Let me zoom in a little bit, just for a moment, where you see how x is between less than signs. This would be read as 2 is less than x is less than 6. And what this means, scroll over, this means the value of x could be any value between 2 and 6. So if you see where x is between less than symbols, let me just zoom back out. This never works. I always try. And maybe this would be the best view. Nope. Sorry, all over the place. Let's go back to this. This is probably the best we're going to get where we can fit everything. So if you see x between less than symbols, that means that x is between those numbers. If you see x between less than or equal to symbols, that means x is between those numbers and it includes those numbers in the solution set. So like between 2 and 6, if we're just talking about integers, would just be 3, 4, 5. But between 2 or 6 with less than or equal to bars, now it's 2, 3, 4, 5, and 6 included here. So do you include those or not? So that's inequality notation. Another notation you're going to see in this course is called interval notation. And basically, instead of using less than or greater than symbols, we use parentheses and brackets. But they work exactly the same way. So, and we typically only see this when we're talking about, well, let me just show you what we're talking about here. So a parentheses is like the inequality symbols without equal to. You know, for example, this is a perfect example here that, 2 is less than x is less than 6. That would be in parentheses 2 comma 6, where the numbers 2 and 6 are not included in the solution set because they're not equal to. If you include the equal to bars, like -5 less than or equal to x less than or equal to 2, that would be brackets. So basically, like the bracket is like that equal to bar. The parenthesis is with the inequality without. And you see some of each, like this one has, a less than or equal to for the 5, but not equal to for the 9. So this will include the 5, but not the 9. So we'll see a bracket for 5 and a parenthesis for the 9. Even inequalities where it's just, not between thing, like x is greater than 4, you can use that in interval notation, but greater than 4 means all of the numbers greater than 4, even to infinity. And anytime you do infinity, it's always going to be a parenthesis after infinity. You never do a bracket with infinity. And then the last thing is whether you're using interval notation or inequality notation, you could graphically show it. So something like x is greater than 3, you see a little circle above 3 and an arrow pointing to the greater numbers. In interval notation, it would look like that. Less than or equal to, when we have the equal to bar on graphs, we color in the circles. Less than or equal to. This is, again, where the arrow is a helpful notation, that less than points to the left. But we're going to color in that circle. See that we have a bracket around the 4 because it's equal to, but we'll always have just a parenthesis. Here we have negative infinity. See this positive infinity all the way on the right side of the number line and negative infinity all the way on the left. 2 is less than x, less than 5. Well, that's parentheses, and there's no equal to bar, so they're both open circles, we call them. And closed circles when we have the inclusion with the equal to bars and the brackets, right? All right, so let's just do a couple quick examples here of what each of this looks like in all these different notations. So the numbers greater than 7 and less than 10. Well, greater than 7 and less than 10, what they mean by that is this. Even though we would probably read this as 7 is less than x, well, that means that a number is greater than 7. If 7 is less than x, the number is greater than 7. Anyways, if you see something like greater than this and less than that, it's talking about the same concept where x is between two numbers. There's no mention of equal to, so it's just less than symbols. Anytime you put x between things, it's less than symbols. In interval notation, that would be parentheses, 7 comma 10. Oh, it's an ugly 10. On a graph, that's 7, 10, open circles, bar connecting them. The actual set of numbers here, would be the numbers between 7 and 10, but not including 7 and 10. So if we're just talking about integers, it'd be like 8 and 9. That's about it. How about numbers greater than or equal to 4? So x is greater than or equal to 4. In interval notation, or let's do the graph first. Sometimes it's easier to do the graph before you do the parentheses and brackets. So greater than or equal to 4, first of all, is going to be a closed circle to the right. As you can see that the leftmost number is 4, and then it goes all the way to infinity. We are going to do a bracket for the 4 because it's a closed circle, it's or equal to, but we always do just parenthesis on infinity. Number less than 5, so a number less than -5. On the number line, that's -5. Here it's going to be an open circle and less than. In interval notation, we see that that number -5 is the number all the way to the right. All the way to the left would be -infinity. We do a parenthesis for that, and we're going to do a parenthesis for the -5 because we're leaving it as an open circle. There's no mention of equal to. Last exercise here, state the integers that satisfy this. So the numbers between 5 and 7, this is brackets meaning inclusive. So this would be 5, 6, and 7. Parentheses 5 and 7 is the numbers between 5 and 7, not including 5 and 7. So that's just the number 6. Bracket for 5 means include 5, 6, but not. Parenthesis for 7 means don't include 7. And this is basically similar to these. This would be a parenthesis 5 bracket 7. So this would be don't include 5, but do include 7. All right, so that's it. So we got to be very familiar with these different notations because what we're going to do in the next video is start solving inequalities, and then our answers are going to be expressed in this type of various forms. All right, see you.